Alright guys, so I'm going to try to explain this washout and wash in business as much as I can, and as well as you can. Hopefully it helps some of you understand this equation a little bit better. Before we get bogged down with all of those figures, we're going to go to a diagram here just so we can help visualize and conceptualize what's going on. So this is our circuit, our breathing circuit. Alright, and just for clarity and for sake of understanding, we're just going to say that this 6-liter circuit is filled with 100% nitrous oxide. All right, and then our fresh gas flow in here is 100% oxygen. All right, so we have nitrous oxide, and our fresh gas flow is oxygen. So washout is concerned with how much nitrous oxide is left in this circuit after so much time. So after 1 minute, how much is left? After 2 minutes, how much is left? And so forth. Wash in is concerned with your oxygen. How much of your oxygen has washed in and what percentage is in there after 1 minute, after 2 minutes, after 3 minutes. How much of your oxygen is now in the circuit, what percentage, and so forth. So that's physically what's going on with wash in and wash out. So let's just go ahead and do a washout equation first. We'll do wash in a little later. But with the washout equation, let's go ahead and isolate this K. So what does that K value even mean? If you remember from pharmacology, K equals clearance over volume of distribution, right? So pertaining back to our breathing circuit, our volume of distribution is 6 liters, all right? And our clearance is how much fresh gas flow is flowing in and clearing this out, right? So let's just go ahead and say fresh gas flow is 5 liters. I have a feeling Dr. Dave will ask a washout equation because you know how he likes to throw us curveballs. Okay, so, and you know what, one more thing. E, don't let E freak you out. E is just simply 2.7, all right? It's a natural number found all throughout nature. It just always equals 2.7. Whenever anything mixes in nature, somehow the value E, which is 2.7, is going to be involved in that equation. So that's what that equals, but don't worry about that. I just want you to get some clarity on what E means. It just means 2.7. So anyhow, going back to our washout equation, let's say Dr. Dave asks, how much nitrous oxide is left? Your anesthetic, whatever, I don't know what anesthetic you'll pick. How much nitrous oxide is left after 2 minutes? So we are concerned about our nitrous oxide, right? How much nitrous oxide is left in here after 2 minutes? So it's a washout equation, because washout is concerned with what was originally in here and how much is left after it's being washed out. Right, so let's go ahead and set this equation up. So y equals E to the negative. All right, so what is our K value? It's clearance over volume of distribution, right? So it's going to be 5/6 times 2 minutes, because T equals time, right? So how much is left after 2 minutes? And if you pull out your handy dandy calculator, you will get that after 2 minutes, there's 18.8% left, or essentially 19%. So that is a washout equation. Again, you're concerned about how much of your original volume is left. So I'll go ahead and upload this, and we'll do a wash in equation next.